James Kachman here from FTC Team 4218, here with Brian May, our electrical build lead. We're going to be talking about a quick tip on how to actually make a better wiring system for your motor controllers so that if something goes wrong, you actually maintain power. Okay, Brian, go ahead and explain the basics.
Okay, so normally, if you use an Anderson connector, you'll see you have two leads connected. However, we double it up so we have 4 leads, and since it on the motor controller and servo controller too, you'll see there are 4 battery slots. We just plug one into each, so that way if one of the wires gets pulled.
How we do that is we take the reds and put 2 into one Anderson connector and then 2 of the blacks into the same Anderson connector. It has 4 wires, but it's still a paired Anderson connector.
And so when we use this, we will plug one into each of the corresponding slots, and so then if one of our wires gets pulled out
or falls out because the thing wasn't tightened all the way,
we still have the other set completely intact.
Which will still make sure there's still a circuit so the motor will still get power and still be controlled.
And for those of you who are new,
for people who haven't used Anderson connectors before,
you'll have the little pieces that you crimp the wires in, and then you'll have the actual casing that you put it in. And so, you'll just take, I guess I'm using black, and you'll need the wire.
That's not.
Yeah, you'll need the wire. You'll need the wire snips.
Here, can I explain this tool real quick? This is actually a 2-part tool. This has a little. Okay, this has a snipper on the end, and then this is a wire stripper, and it's just a 2-part tool. We don't actually use this. There's a lot of things we don't use this for, like cutting of zip ties and cutting metal pieces. Why'd you get metal pieces on one of these? But we don't cut a lot of things with this. We don't break this because these are valuable and really handy.
And it's my favorite tool. Okay, so you'll cut the wire, then you'll strip it, and then you'll take your crimper.
Make sure you show it.
You'll take your crimper. Ours looks like this.
Make sure your stripped wire looks like this, so you have exposed metal wiring on it. You don't want to go too far down on the insulation, otherwise you'll have exposed wire, which is very, very bad. But you want to make sure you go down enough so you have enough exposed wire to actually work with.
Okay. And so then, what I personally like to do is before I try and crimp it, I'll just twist those 2 wires together. As you can see, I put the little casing in there. Well, the metal piece in there. I'll just put the wire in.
And then just lock it down.
And there you go. You have 2 connected into one.
And then you put that into the Anderson connector, so then they're both locked down.
Now, and one thing about Anderson connectors, make sure you push it down until you hear a click. Otherwise, the metal piece, see, it's in.
If the metal piece is sticking out, you need to push it down more. There should be an audible click once you have it pushed in enough.
Yes, because if you do not get that click, like right now, I don't think it's clicked in.
It'll just come right out, and that's bad.
So you want to make sure that when you do it, that every single time, you make sure you get it all the way in.
But then one of the advantages of Anderson connectors, even though they take a little bit more time to actually work with, is instead of having to take wire lead to wire lead and then do that, I can simply take the Anderson connectors and basically plug them in together, and that's a solid connection, and it takes a bit of force to remove it. But if I do want to remove it, it's nice and modular, so I can change wires around. Several times we've actually fixed broken wiring jobs or fixed a faulty wiring job simply by plugging in and rewiring Anderson connectors. It makes it a lot more durable and a lot more versatile.
And then another thing with the connections, if you're using them in a high intensity area and
they're likely to break.
Yeah, or where like you have moving parts and you practice and they get pulled apart a couple times, just plug them in, wrap around some electrical tape
to make. Sorry, we had onlookers. But you can wrap it around with tape to make sure it doesn't come out and just give it a little bit extra stability. Also, what we have done in the past is we'll actually take this and label this connection. So it refers to a specific motor or a specific motor controller, so we keep track of the wires. In previous times, we'd have like just a jumbled mess of wires called the rat's nest. We have several amusing stories about, but it's not very effective. Yeah. However, when you do something like that, you can very easily remember which wire goes to where, and then if there is an issue, easily identify where the issue is. And it works really well because programming has to do stuff like that. They have to label their wires, and they have to understand how the wiring works. So if you, the hardware people, know, it makes programmers' job easier, and we like happy programmers because happy programmers do their job. Unhappy programmers yell at us and get a lot of headaches. So this is, even though it takes a little bit more effort can go a long ways. Okay.
And did you have anything to talk about for this episode?
Nothing else.
Okay.
I hope this was an educational video. I hope you guys are having fun with robotics, and hope you have good luck with your robot. Bye.
See you later.